In this video, we're going to talk about one-step equations that have multiplication in them, okay? As we look at our equations, in solving an equation, we have a few steps that we have to go through and a goal that we eventually want to get ourselves to. First thing we have to do is we have to recognize what function or functions are present in the current equation. Now, in each of these equations, you will notice that's 3x equals 8, 9x equals 4, and 12x equals negative 3. So 3x, that's 3 times x, 9x, that's 9 times x, and 12x is 12 times x. So we recognize that multiplication is the function that is involved in each of these particular problems. So I recognize the function. To undo that function, which is my next step, I have to use the opposite function. So the opposite function of multiplication is division. So I'm going to divide both sides of the equation. And why do I divide both sides? Because it is an equation. We think of it like a scale. So currently it's balanced. So as we look at our first equation, 3x equals 8. So 3x and 8. So those are balanced. They're equal to each other. So if I divide one side by 3 and I don't do anything to this side, then they're going to be a little balanced, off balanced, okay? So in order for us to keep it balanced and keep them even, I have to divide by 3 over here, and I divide by 3 over here. On this, and I do by the same number. If I just divided by 4, it wouldn't do me any good. I have to divide by the same number that's given to me in the problem. Remember, our ultimate goal is to isolate the variable. What does that mean? That means I want the variable all by itself. Nothing added, subtracted, multiplied, or divided by it. Okay, I want the variable by itself equals a single solitary number. That's what I want. So our first example, 3x equals 8. 3 times x equals 8. So I undo multiplication by dividing. So I'm going to divide both sides by 3. Divide by 3, divide by 3. Those two 3's are going to cancel each other out. So now I'm left with the x equals 8 over 3. Now you can convert that into a mixed number if you wanted to, or you can just leave it as an improper fraction, depending upon how your classroom is structured for that. In my classes, it really doesn't matter for my kids. I will take it in either way. All right, so let's look at our next example. 9x equals 4. 9 times x equals 4. So to undo the multiplication, I have to divide by 9 on both sides. Remember, I have to do it to both sides. These two 9's will cancel each other out. X equals 4 over 9. I can't simplify it, so I can leave that as my final answer. That's perfectly okay. In our last example, 12x equals negative 3. 12 times x, again, times, so therefore I have to divide to undo it. I divide by 12 on both sides. The 12's cancel. X equals negative 3 over 12. Now, many of you are probably sitting there thinking, you need to go ahead and simplify that, and I'm glad you mentioned that. So I'm going to go ahead and do that. I need to find the greatest common factor that goes into both of these, into 3 and into 12, and it is a 3. So 3 divided by 3, remember it still stays negative. 3 divided by 3 gives me 1. 12 divided by 3 gives me 4. Now part of our solution, part of our method is also to check and make sure our answers are correct. And how do we do that? We plug them back in. So I look back up here, and I'll just do one of them here so that you see that. So we have 3 times the quantity, 8 over 3, equals 8. So that should not be, that's where we go. So 3 times 8 thirds. Okay, remember that's 3 over 1. So 3 times 8 gives me 24. 1 times 3 gives me 3. We just move the 8 down. So what is 24 divided by 3? That gives me 8 equals 8, which means that my solution is correct. And you can do that with each of the problems that we have there, okay? Remember, recognize the function you're given, undo that function by using its opposite function, but with the same number, so that we can isolate the variable. So all I have is left is my variable equals a single number. All right. Thank you.